Okay, so here we go. We're starting a new unit today. This is Unit 2 and Module 4, talking about lines and angles. So, I widened the board so it should look a little bit bigger out there, Bo, and those of you in the back. It should look a little bit bigger than what it has in the past. It's probably about 50% wider. So, all right, so let's first of all review what a line and an angle is. All right, so a line, this would be for your notes. A line is represented with arrows on both ends. But we also have it labeled with 2 points. And many times it looks like that. That would be line AB. And that could also be line BA. It does not matter in which order we name the line. Okay? Another thing that we've learned about a line is that it has 180 degrees. If we were measuring it with an arc or a protractor, a line has 180 degrees. Okay? Okay, so all that's review, things that we've already discussed. Now, a little bit more about an angle. We've talked about an angle like this, where an angle has a vertex and then 2 rays. So this would be a ray, and that would be a ray. But there's also angles created when we have the intersection of 2 lines. In fact, there's a lot of angles created. Let's see if we can count them. Okay? All right. Follow along with me. 1, 2, 3, 4. Now, if we start here with 1, there's another angle. We'll call that 5. There's another angle. We'll call that 6. See all the different angles? Without repeating ourselves, we've got this angle. It's still 180 degrees, but it's a different angle. That would be angle 7. All the way around here, that'd be angle 8. You getting the idea? I mean, there are a lot of angles. But typically in this picture right here, we limit ourselves to these 4. And that's what we talk about. Now, we know that these 4 angles, we have acute and obtuse. That's one way to describe the type of angles they are. We have acute and obtuse. So let's see. Let me pause there just as this is all background, by the way. We've done all this. This isn't nothing. I haven't said anything new. Okay, but it's a good refresher. All right. All right. So on page, I think it's 162. Is there a definition on page 162? I might be on the wrong page. No, it might be 164 then. Vertical angles? No. What is it? I'm sorry, it's 164. Page 164. Go ahead and write in your notes the vertical angle theorem. Maggie, you did all right. All right, you got the vertical angle theorem in your notes? You want to go into it a little more detail.
I wrote this in.
It's okay. Okay, they got everything written in? Jalen, good? Chris? All right, so let's say that we have two lines which intersect right there. Okay, so go ahead and make, this is just an example, it's not in your book, this is just an example I'm creating. So go ahead and make another pair of lines and they intersect, all right? Now, what I want you to do though is look up here on the screen and let's talk about this a little bit more detail. So don't look at your paper, only look at those two angles. You see those two angles? Anybody know what they're called when they're right next to each other? Do you guys remember? Okay. They're called adjacent angles. Remember, I used the terminology, in fact, I probably used this example in here, that an adjacent neighbor to us are the Bodkins. They live next door. Remember that? They're not across the way. They're adjacent. They're right next door. Okay? And so angle 1 and angle 2 are adjacent angles. Now, more specifically, because they add up to be 180 degrees, they are what we call a linear pair. The linear pair are adjacent angles whose sum is 180. You remember talking about that? It's been a while. But so angle 1 and angle 2 would be what we would call a linear pair whose sum is 180. Which makes sense because I think we all see that that's 180 degrees, right? I don't know what the measure of each angle is, but I know their sum is 180. Is everyone okay with that? Okay. All right, so now I'm going to go ahead and put 3 and 4. Now let's come back to our linear pair idea. And let's just say, for instance, in our little illustration here, that angle 1 is 150 degrees. So from here to here is 150. If that's the case, Jalen, what would the measure of angle 2 be? If we know that it's a linear pair, everything's 180, if angle 1's 150, what would angle 2 be? Can you do that math in your head? Yeah. Does everyone see that and agree with her? If this is 150, this one has to be 30. Right? See that? Okay, good. Now, let's change your view a little bit here. Okay. It's a straight line, right? What's the degree measure of a straight line? So if from here to here is 150 and the whole thing is 180, how do I find? Hope we good? Okay, so let's come back over here now. Now, only look at angle 2 and angle 3. Hope, this angle is 30. We just determined that. If that angle is 30, what's the measure of that angle? Hope. Huh. Interesting. She's right, but interesting. Let's keep going. Let's change your eyes again here. Now let's only look at 3 and 4. Michaela, if angle 3 is 150, what's angle 4? We know all, that's a straight line. So this whole thing is 180. If this one's 150, then what's left over? 30. Does that make sense? Okay, so now look at this. Let's look at everything together. Vertical angles are across from each other. What's true about vertical angles? They're congruent. We just proved it. Okay? And we just proved it by looking at just two lines, using the idea of a linear pair, 180 degrees, and those. They're always equal. Always. So vertical angles are always equal. Okay? We don't get to say always very often in math, but we can here. They're always equal. All right. Good. Let's keep going. Now, on page, let's get the right page number. Bottom of page 166. Mo, can you read off number, your turn number 6? Hold on, let me get ready here. Page 166. Your turn number 6. All right, go ahead.
The measure of two vertical angles are 58 degrees, and 3 times 3x plus 4 degrees. Find the value of x.
All right, if they're both vertical angles, how are they related? It means they're equal to each other. So Bo said that one angle is 58 and the other one's 3x plus 4. Is that right, Bo?
Yes.
3x plus 4. So they're related because they're equal. All right, go ahead at your seat and solve for x. Go ahead at your seat and solve for x. Go ahead at your seat and solve for x. Chris, what'd you get? You can't solve for x? Okay, so back to algebra 1, Chris. If we're trying to isolate the variable, so this is the variable we're trying to find, how do we undo what they're doing to our variable? What's the first thing I have to do to this 4? Subtract 4 from both sides. Because whatever I do to one side, I have to do to the other side. Remember that? It's okay. Hey, we had to take off April, May. I mean, we've taken off a lot of time from your Algebra 1 stuff. That's okay for us to review this. It's all right. Okay, and so 58 minus 4 is 54. 4 minus 4 is 3x. Now what do? We have to undo what they're doing to the variable. That's right. Divide by 3. So now we divide by 3. 54 divided by 3. That's a hard number. So it's 18. 3 divided by 3 gives you x. Yeah, I gotta subtract 4.
Well, I did. I just forgot to write it.
All right. Any questions on that? That's how we solve. Okay. All right. Bo, can you read off number 7, please? Oh, the reason I pick on you to read off because you're in the back of the room, and that way everybody can hear.
The measures of two vertical angles are given by the expression x plus 3 degrees and 2x minus 7 degrees. Find the value of x. What is the measure of each angle?
Okay. So we're going to do pretty much the same thing. Here's one vertical angle, here's another vertical angle. Since they tell us the vertical angles, we know that they're equal. So I can set up an equation. Once again, let's review our algebra. Go ahead and solve.
Would you?
Gotta get the x's on the same side. Yep.
Okay, that's the first thing you do.
Mm-hmm.
Like I did not do that. Never mind.
Mason, you confident? What'd you get for x?
I got an answer.
Sure, what'd you get for x? For x. Okay, not quite. You're close.
What did you say?
He said 8. That's not right. No,
Negative
it's not.
7.
No, it's not. Oh. It is 10. All right, Mason, that's okay. Let's take a look and see what we did, okay? All right, algebraically, the first thing we do, Maggie asked this question, some of you didn't hear it. The first step we have to do is get the x's on the same side of the equation. Since we have an x over here, we have an x over here. Now, we could subtract that 2x and bring it over, but that's harder because then you end up with a negative coefficient. And so the best thing to do is subtract x from here and here. Whatever I do to one side, I do to the other. So my first step, as you can see, is I subtract x and subtract x. So then the x's on this side, what happens? They cancel. What am I left with over here? Just 3. Over here, 2x minus x. Now that's just 1x. So 2 minus 1 is just 1. I didn't do anything with the negative 7, so it's got to stay with it. You can't just drop it off. It's got to stay with it. Okay? Now it's kind of like what we were doing up here. I have to undo. I use this terminology a lot. You can probably remember this, but you want to undo whatever they're doing to our variable. And in this case, they're subtracting 7. To undo a subtraction, we have to add 7. So to add whatever I do to one side, I have to do to the other. Have I done my riddle for you guys yet about the scale, this kind of scale?
No, good.
Have I done this riddle for you guys? You guys know the old time scale, you know what I mean? Like the one for a lawyer, you know, like you see the bout. You guys know that? Have I ever done my riddle for you guys for this? Nice. We might have to do that tomorrow. Don't let me forget, Elise. You're in charge. Okay? A riddle. All right, so now, when we take 3 plus 7, we end up with 10. And that's how Hope got. So, Mason, if you don't mind me asking, how'd you get 8?
I had a 7 on both sides.
Oh, okay. And you know what? That's not a bad idea. That would give you 10. But then what'd you do with the x? Oh, I see. When you... No? Because you can add 7. That still got you there.
I don't know what I did wrong.
Okay.
Yeah, I added 7, that's what I thought.
Yeah.
Probably had a 7 maybe just the 2 and the x subtract the 10 from me.
Oh,
That's
could be.
exactly what I did.
Okay. Yeah, because you had to subtract the x, and so you end up with 1x, not 2x. Okay, now, Bill, back to you. When you read the question, it says solve for the value of x, right? What else does it ask for? Okay, so that means we haven't answered the question completely. We have to take the value of 10, and we have to plug it back in. So I did it on both sides. So this angle was x plus 3. So then we put 10 plus 3, we get 13 degrees. Since they're vertical angles, they're equal. This side better give me 13 degrees as well. 2 times 10 is 20 minus 7. And about 13. Got it? Good. We got one more concept to cover, and then we're going to give you some time to work on your homework. A couple problems. Okay, so now this needs to go in your notes. All right, so we understand the idea of supplementary. Two angles which are supplementary are their sum is 180 when they're supplementary. When they're complementary, their sum is 90. I don't think we've talked about that yet. This is a new term for us. Complement, supplement. The two angles are supplementary, sum is 180. When the complementary, sum is 90. All right, now, watch this. Let's do some math in our head. We can do this, okay? If I tell you that one angle is 100 degrees, and then I say, okay, Michaela, what's its supplement?
180.
No, the whole angle is 180. The whole thing is 180. The supplementary angle's sum is 180. If one of the angles is 100, then what's the other angle? Thank you. Good. Let's do that again. Let's do another one. If I tell you that an angle is 60, Chase, don't help her out. Chase, what's the supplement? Good. You guys following it? Okay, let's do another one. If I tell you that an angle is 150, Kylie, don't help her out. What's the supplement? So both of them add up to be 180. If one of them is 150, how much is left over? That's right. 100 plus 80 is 180, right? 60 plus 120 is 180. 150 plus 30 is 180. You guys following the pattern? All right, Colby, let's get you involved in this. If one of the angles is 20, what's its supplement? Nope. Colby, both of the angles have to add up to be 180. Oh, maybe that. Oh, okay. Well, good. Let's get you involved now. So let's see. 100 plus 80 is 180. 60 plus 120 is 180. 150 plus 30 is 1. Thank you. See, I thought you could get it. All right, Bo, let's give you a tougher one. One of the angles is 85. Don't use your calculator. 95. Very good. Elise, we're going to give you the toughest one of all. One of the angles is X. Anybody? Chase? Hope?
Okay, we're doing 79.
Okay, close. That's not a bad idea, but we don't know the value of X. It's not value of 1. Nicholas?
You need the other angle.
Which is?
It would be x plus.
Not quite. He's on the right path. Chase?
180 minus X.
Outstanding. Very good, Chase. All right, so now do you guys understand that? Now, hold on, let's explain. It's not as difficult as you might think. How did we find each one of these angles in red? Well, you should have just subtracted from 180. And so 180 minus 100 was 80. 180 minus 60 was 120. Do you see the math? And so then, if this is x, then this is 180 minus x. So, Bo, if this is y, what would this be? That's right. Pretty simple. Does that make sense? Okay, so now let's go to complement. We're going to do the exact same thing. We'll do this one a little quicker. Okay? If the sum is 90, if one of the angles is 60, what's the complement? Anybody? 30. Thank you. If one is 45, what's the complement? 45. Good. If one is 89, what's the complement? And then if one is x, what's the complement? All right, you guys get the idea. Okay? And so, we're going to use this idea for our next type of problem. An angle and its supplement. An angle and its complement. Okay? All right, so turn to the top of page 168. Top of page 168. Bo, can you read that paragraph out loud? The paragraph that Bo's going to read is basically what we just talked about, but I don't think they explain it very well. That's why we took the time to explain it. All right, so go ahead, Bo, the entire paragraph there.
You can represent the measures of an angle and its complement as x degrees and 90 minus x degrees. Similarly, you can represent the measures of an angle and its supplement as x degrees and 180 minus x degrees. Use these expressions to find the measures of the angles described.
Okay, so that's what we're doing. And that's why I just established for you how in the world did they get those expressions. Does that make sense? Okay, good. Now let's go to number 10. Elise, can you read that one aloud, please? I'm sorry, number 9. Let's do number 9 first.
Okay. The measure of an angle is equal to the measure of its complement.
Okay. Now there's our equation. Now, so I'm gonna be rude. I'm gonna have you read it again, and I'm gonna interrupt you as you read. Okay? So go.
The measure of an angle.
Stop. The measure of an angle we're representing with just an unknown. We don't know the measure of an angle, so we're calling that x. The measure of an angle. Okay, go ahead. Stop. Whenever she says the word is, what do we do in math? What's that mean? It means equals. Whenever you see the word is, that means equals. So that's where I've generated the equal sign. Hence an equation. Okay, go ahead.
Is equal to the measure of its complement.
All right, and 90 minus x, we know, is the measure of its complement. Do you see how from the words that Elise read off, we've created an equation? All right, so let me rewrite it without all the mess. Now we're going to solve for x. It's not as hard as it may look. Go ahead at your seat. Solve for x. I'm going to add x to both sides. Got to get my x's on the same side. Lenny, what'd you get? No, Laney. They're not done. Not sure? All right, so here's the equation. We got to add x to both sides. This x over here. We add x because we want to eliminate the x over here. When you take x plus x, what do we get? 2x. That's equal to 90. Remember, we just add the coefficients. There's a 1 there and a 1 there. That's 2x. Now we're trying to solve for x. So now I divide by 2. Then the 2's will cancel. 90 divided by 2. And our two angles then are 45 and 45. Okay? Good? All right, Elise, back to you. Go ahead and give us number 10. I'm going to slow you down. Okay, go ahead.
The measure of an angle is twice the measure of its supplement.
The measure of an angle is. So I'm going to go there. That's how I'm starting. The measure of an angle is. Okay, now the second part of that, Elise.
Twice the measure of its supplement.
Twice. I'm more than 2 times your age. Take your age times 2, right? Twice means we multiply. The measure of its supplements. We've already said 180 minus x is the supplements. Does everyone see how I can create this equation from the words? Because you're going to have to do that on the homework. All right? All right, now, algebra. The first step on this, go ahead and solve it at your seat. But the first step on this is I'm going to distribute 2. Okay, let's see how we did. First thing we're going to do is distribute the 2 to both terms, the distribution property. Okay, and so when we do that, we end up with x equals 360 minus 2x. Because the 2's got to go to both terms. Okay. Then we've got to get the x's on the same side. They can't be on opposite sides of the equal sign. We're going to add 2x to both sides. The negative 2x and the positive 2x, those cancel. That's why we're doing it. And so x, which has a 1 as a coefficient, and 2 makes that a 3x, and we have 360. How do we undo multiplication? By division. So we divide by 3. So the 3 here and the 3 here will cancel. X on the left. Then 360 divided by 3 is 120. So then the measure of 2 angles of an angle and its supplement, 120 and 60. It said find the measures of the angle described. So this is the measure of the angle, which would be this angle. And then the measure of its supplement would be that 180 minus that, which is 60. If it asks for a supplement. If it asks for a complement like it did over here, then we have to get it to 90. That's the difference. Okay. All right, turn to the next page, 169. Your assignment is just 1 through 12. About everybody in second period got completed. It is due tomorrow. Okay, let me get this posted on the campus.